Sigma-delta converters for the use in general-purpose data acquisition. At Hi-Techniques, we're frequently asked why we don't use sigma-delta converters for our data acquisition systems. Developed for the high-volume and cost-conscious digital audio marketplace, 24-bit sigma-delta converters offer the potential for high resolution at a very low cost compared with traditional analog-to-digital converters. To understand the benefits and drawbacks of sigma-delta converters, it's important to understand how they work. A sigma-delta converter is a high-speed 1-bit ADC which utilizes a comparator and digital filter circuit to build up a 24-bit representation of the waveform using the oversampled data. The internal digital filter has a flat passband and sharp filter cutoff to allow a bandwidth near the Nyquist frequency. The steep characteristics of the sigma-delta internal filter make it unsuitable for many data acquisition applications where step response is important. Let's take a closer look using a typical impulse-type waveform. The waveform shown from a standard DSO has a faster rise time and slower fall, representative of many data acquisition applications. Here are the same waveforms captured using a standard 16-bit successive approximation digitizer. By increasing the time base, you can see the relative stability of the waveform. You'll notice the level of the top and bottom of the waveform are relatively stable from cycle to cycle. Now let's take a look at the same waveform using a sigma-delta converter. You'll notice a significant and variable overshoot and preshoot on the waveform. This overshoot is often referred to as the Gibbs phenomenon. It's the result of the inherent filtering on the sigma-delta chip itself. Notice the overshoot and preshoot on the waveform and the variability of that distortion. The peak error can vary from near zero to over 20% depending on its rise time and precise timing on the edge within the sigma-delta oversampling period. Therefore, there is no way to know how much error is contained in the time domain waveforms. Here you will see the amplitude error on 100 consecutive pulses and the comparison on a standard high-resolution data acquisition system. You'll notice that the amplitude errors can be as much as 22%, meaning that the 24-bit digitizer is only providing 2 bits of accuracy. Since many engineers need to measure both frequency and time domain signals, any instrument using a sigma-delta can be very restrictive. The best instruments, such as the Hi-Techniques Synergy, provide selectable filtering depending on the data being measured. The filter effect of the sigma-delta can be easily demonstrated on the Synergy simply by inputting a standard square wave and toggling between steep and Gaussian filters. The steep filter is almost identical to that of a sigma-delta filter. The low cost of a sigma-delta converter make it ideal for frequency domain or audio applications where they provide excellent dynamic range and performance. For time domain applications, the traditional 16-bit successive approximation converters provide up to 100 times greater peak accuracy. Please visit our website for more information on this and other topics.